Sorry for a bit of delay, but then I think we can go ahead. I'm standing between your coffee breaks, so yeah, I need to go very quick. All right, so for the topic for today, I'm going to touch on reverse engineering Android malware. Really talk about attacking on Android application, but I will focus on how you can reverse all this stuff, right? Regardless of either it's running on app or running on as a malware, it really doesn't matter. As long as within the Android format, how we can reverse engineer it. So a little bit about myself. I work for Cybersecurity Malaysia, which is part of under my department, which is leader group of malware research group. Our agenda, we're going to cover on the intro about what is Dalvik, what is JVM, and so on and so forth, and a little bit about Android and malware, and of course about what is essential tools or skill that you need to know when you're dealing with Android reverse engineering. And of course, we're going to show a little bit about at least 4 samples on the malware, on Android malware, and of course, we're going to touch a little bit about a challenge and issue when you're dealing with the reverse engineering on an Android platform. And of course, the last one is about conclusion. So Android malware. So this is your Android malware. So Android malware statistic. This is statistic was released by a guy. If you take a look at this web page, so he did some monthly analysis for each new sample found in the wild. So roughly, you see a lot of sample found in the wild as well. Or I would say a lot consider the new kind of platform for the mobile thing. It's not really legitimate if you want to compare platform on Android and Windows, for example. Okay, so this is kind of a statistic on the malware, Android malware. And then the news is pretty much everywhere nowadays. Here you have 1 year here, you have a Trojan spy on your conversation. Pretty much everywhere nowadays. All right. So Android malware is pretty much a malicious piece of code. Infection method of Android will be different than typical Windows infection, right? One of it is using a lot of things that we saw is by doing some modification or doing some repackaging to the legitimate application, such as like Genie, Dreamdroid, pretty much, for example, Answerboard. The latest one is Nikki Spy, and so on and so forth. And normally all these, repackaged application will be uploaded to the third party hosting or upload back to the market. Okay, and the second one is probably by exploiting Android core or application bugs. Like for example, you can exploit WebKit, especially on the Froyo 2.2, 2.2 Froyo I think. So there is like a WebKit engine bugs on the browser, so you can pretty much hack, break into the browser and try to execute shellcode that will install your application. And then also there are also fake applications as well. Like people are talking about Dreamdroid removal tool back to on the April, if I'm not mistaken. And there is also people try to abuse that by releasing fake application, which is a malware by itself, to pretending to be removal for Dreamdroid. And of course, the latest one is SpyEye fixed security tool. Well, don't worry about SpyEye sample. We're going to do some analysis on that later on. Infection method, the last one is probably doing by remote install. For example, if I can compromise the Gmail account, and then that is like a web-based application installation, which is only required for Gmail credential, you can pretty much log in and do installation on behalf of the compromised victim. Okay, so you can do remote install over the market. So reverse engineering Android malware. So before you start doing reverse engineering Android malware, the thing that you need to understand the nature of files of the application. For example, for the Android application, they normally go with the APK, which is pretty much a zip file. So you need to extract a DAX file inside there. And then you can do reverse engineering by, you can do static or you can do interactive debugging. It's possible due to the fact that you can do some installation on top of the APK file. And then the last one, for example, some people probably just only want to share .dax with you, which is .dax is pretty much the file inside the APK. Okay, so only reversing is possible. Few files or folder will be missing. For example, resources, asset, and Android manifest is going to be missed. And then this is pretty much the building process for building application. For example, the first thing that you need to have is a .java application. Okay, you need to code in Java, and then of course you need to do some compilation to get .class of Java. And the last thing you need to do is doing some DX to get the download format. Okay, then of course the last thing is you need to repackage into the application APK application. And normally if you're running kind of SDK, it's generated automatically for you. So that is on the building process. When it comes to reverse engineering, you always need to go the opposite way, right? So the first thing that you need to know, you need to have now is the .dex class. So .dex normally look like this one. So this is the language of DEX, JVM, bytecode. Okay, you have classes, you have virtual method, and you have function here, and so on and so forth. So this is on the DEX from bytecode. And when you want to convert it to disassembling, you need to use a method called disassembling. And a couple of tools for doing disassembling, you can use Bugsmally to do disassembling. You can also use UnDX to do disassembling as well. So you're going to receive classes. It depends on tools that you use. And maybe you can receive a download disassembling output, which is look pretty much like this. Before this is not really readable so much, but this is, well, it's acceptable, I think. It's readable and it's still acceptable. You can pretty much understand, for example, this one, this is a field for the variable SMS received, for example, okay? And normally when you come to the next stage, you try to convert everything to the original code, which is, in reverse engineering, normally we call it decompiling, right? So you need to have a decompiling, which is going to turn back into the Java code, which is going to look like this, okay? So this is pretty much the Java. So that's pretty much the reverse engineering process for the Android. Okay, a couple of tools that you can use. Disassembler, like I said, you can use Bugsmally. You can also use DDX, NDX, DexDump. DexDump will generate the first download bytecode. Okay, and then assembler is do some modification on the assembly code, and you want to reassemble back. You can use assembler like Smally to reassemble back. And of course, Bugsmally and Smally is somehow being repackaged to the another tool called APK tool, which is I think really mentioned previously. So this is a bunch of tools. Text editor, when you want to do reverse engineering, of course you need to text editor to just reviewing all this file. And Notepad is fine, I think, but you can have like a syntax highlighter. Feel free to use a couple of Vim can support the highlighter. And last tools is probably Dex2Jar. Dex2Jar do some decompiling for you. Like you give the tool, the .dex class, and it will convert to a .jar. And you can open with the JD get to open the Java class to the Java code. Okay, so that's a couple of tools that you can use. When you start reverse engineering the Android application, you need to understand where is your starting point, where you want to start. For example, when you reverse C++, for example, you're always looking for main. For example, you're looking for main function, right? On this one, you can always refer within the Android manifest.xml because it's pretty much define the behavior of the application. For well, we have a sample, so we can take a look on this one later on. Well, it's pretty much a binary data encoded, so you can use tools like APK tool to decode it. And inside the Android manifest.xml, it also have a permission request. Like when you install an Android application, we tell you this application require this permission and so on and so forth. Okay, and it's also give you entry point. For example, if this intent, what is the service need to start? If this intent receives, for example, you have a state of Wi-Fi connected, so that's just pretty much your intent. So which intent, which services or which code that need to respond to that state, for example. So it's normally defined within this receiver, intent, action, service, and also activities. Okay. So take a look at this example. This is Android manifest.xml. Take a look at this one. So it's pretty much, for example, receiver for this one. If the action of your phone, or your Android phone, have action of smf.receive, which is when you receive an SMS, so there is a code that's going to respond to it. So in this case, it's pretty much the class of SMS receiver will be respond to it. Okay, so that is the way how you you navigate your code analysis by looking at Android manifest.xml. And of course, one of the important things about Android manifest.xml is the user permission. For example, if your application is only for playing game, for example, you have like a game application. Well, game application probably don't need to receive SMS or send SMS, right? So you know that probably something is wrong with the application. So this is also, you can start looking at which within the code going to look for this kind of permission, and then you can start your analysis on that particular code. Okay. All right. And well, reverse engineering pretty much is solving a puzzle. So when you're dealing with the huge code base of Android application, because if you notice, if you have a free application for Android, it's also bundled together with the, sometimes they're also bundled together with the, kind of like ad application. So you have like pop-up for app or something. So sometimes you also tend to analyze on the ad application as well, which is probably, I think, it's not probably best thing to do, because that's probably not the first place the bad guy going to modify the code, right? So always try to starting with the grep and looking for suspicious string. For example, NAT and crypto, server, SMS, phone, or whatever you can think that it's not supposed to, something that's suspicious for you, all right? And of course, try to look for like a suspicious API. For example, looking for SMS API. Like for SMS API, there is like standard calling function for it. Like for example, you want to call SMS receiver, you need to start like a get PDU, and you can get default, and you get number and so on and so forth, so that you can construct properly the data of SMS. And of course about mail API, network API, so that's just probably your starting point when you analyzing Android application. And of course, when you reverse new bytecode or new code, you need to understand the bytecode out of it, right? If you reverse engineering Java, you have to understand Java bytecode. If you reverse engineering, Mac OS, you need to understand Mac OS as well. So same goes on the Android. So Android pretty much rely on dynamic bytecode. So you need to understand the nature of dynamic bytecode. Git documentation, of course, at Android git.kernel, and this is also good reference as well from Gabor. Gabor code tool called Deduxer. So pretty much the data here is based on his reverse engineering on the DAX opcode, DAX bytecode opcode. And this is also a couple of opcode. And this is also a good reference to understand the API call from the Android XDK. So this is pretty much the Dalvik bytecode. For example, you have dot class or something, and you have super. It looks like similar to the Java, right? If you're familiar with Java, it pretty much looks similar. But in terms of function, like for example, invoke something is have many invoke. For this one, you have like 5 invoke. So you need to understand for like invoke direct, what it means by invoke direct, and invoke interface, how it will reflect your result out of it, right? So you need to understand of this. And for example, like asGet, asPut, what it mean by that? Like, does it return array? Does it return object? Does it return interface and so forth? So we need to understand pretty much the language of the Dawei. So for example, this is loop, this is move, this is like if else, like go to something, and this is get, and this is I get, this is integer get. So there are many of it that we need to understand. Like if, for example, you create array, what kind of return out of it, and this is like if something, like if not equal, if greater than something, and if little than something. So there are a lot of things that we need to understand on this, right? So that's pretty much a starting point when we try to do reverse engineering. So this is pretty much case study that we run in our lab. So the first thing is, many of family in Android malware. So the first one is January SMS stealer. This one, the sample that we have here, is pretty much interesting. Why this is very interesting? If you take a look at this, if you follow any Android application tutorial, we're going to start with this, like Android application 1, like example 1 of something. So the guy follow exactly the same concept, but instead of doing something cool, he's doing something else, like stealing SMS. So this, so like for example, I mentioned you can start looking for suspicious name. So this one, like you grab something and you look for SMS manager. So you know this code has something to do with SMS, right? And so on this sample, the good thing about this sample, I received this sample without .apk. So I have no Android manifest.xml in it. So I need to start thinking what is probably the most common sense when people write code, and what is the first function that's going to be executed, right? Because if you have Android manifest, you can look at the Android manifest and find your entry point. But if you don't have, you need to start looking at the code. And normally for the Android application, if you have init, on create, or on init, on cnit, this is probably the best place for you to as a starting point. So you need to inspect all the code. So in this case, well, the application is about doing SMS, but it has a file name called movie player. It's been branding as a movie player, but it's also it's not doing anything is about movie at all. Just steal your SMS, okay? So inside this code, there is a function like if you take a look before this function, movie player, have something that have API call to the SMS manager. So it's pretty much a good place for us to start, right? And if you take a look at this, for example, init, so this is the place that we can init, onCreate. So this is probably the good candidate for you to start your analysis, right? And this is also a very easy example because it only has like 3 files. So it's much easier for you to do analysis. And then if you're using this kind of approach to analyze one of the cool Android malware is called AnswerBot. I wish good luck for that, because a huge file roughly have about like 50 dot classes, which is quite a lot of numbers of classes. And then if we inspect on create, take a look at this example. So you start something like on create and doing some text view, and this is when you click on this application. You click at that application, it's going to give you some text view, like thanks for clicking me. But in this sample, it gives, this is not really garbage, it's kind of Unicode in a Russian language. So as I recall, it says something, please wait, we're doing something, all right? And the next step is, try to call get default, which is calling from this SDK for the SMS manager. Right? So get default is pretty much get, like I mentioned, you need to have like a proper API calling method to get the SMS. So the first thing you need to do is try to get default of the SMS manager. And later on, so this is get default, this is something and something, and the next, so this is the way you start to, crafting your input. When you, for example, the next call is probably send SMS to something, right? So, for example, you want to steal SMS, and then you want to send to different numbers, for example. So you need to properly craft. Like if I want you to SMS to this number, so you need to craft your your data. For example, this is the number that you need to send. So this is the result of get default. So this is your SMS, this is the text, and this is the numbers, for example. And the next thing is call a function called send text messages. Okay, so if we send by providing this is the parameter that you need to send, like from V0 to V5. This is the parameter for the function send text message. So how you get the parameter is by crafting this, like a V0, V1, V2, V3, and V4 and V5, right? And then you send the SMS. And it's not only one, you send multiple times of it. And, oh, sorry, this was an SMS stealer. It's basically SMS tool fraud. So when you send like premium numbers, and you get credit out of it, right? So this is pretty much how the guy get money out of by sending SMS using your phone numbers. And he's only sent 5. Why? If you send non-stop, it's probably dumb, right? I mean, people are going to be running out of credit, right? But if you send like 5, who cares? You lost about like $5. Well, people are probably not noticing, right? And it also have mechanism like the last one. It called a function was, mean to modify some data to be like next when you run. If the was is set for 1, then please do not send this another SMS. There's only 5 times and that's it. Okay, so this pretty much for these SMS data. Right, was, so then it just finished. So it just closed it just terminated the application. And then, well, one of the huge malware on the that creates huge wave of Android is Dreamdroid. The good thing about this Dreamdroid malware is it bundled together with jailbreaking tool. So if you install this malware, well, your phone will be jailbreaking by this guy. So it's very famous in this one. It's modus operandi. It's infecting legitimate software. We have roughly about 53 software infected by this variant. And the good thing about this is also hosted at the marketplace. So you probably Google, like you try to search for something like playing game. One of the things that we analyze is a monkey jump application. So you search for monkey jump, which is a game. You probably have extra features of the monkey jump, which is Dreamdroid malware. So it's bundled together with a 2 exploit, which is exploit, CVE 2009-1185, and the latest one was Rage Against the Cage. And this is also good on this one because this is the second publicly known malware that have the bot capability. When I say bot, it means like it can send you something and then your phone will be respond to the malware. Well, take a look at the life cycle. It's also based on intent, based on launch. So it's just a fake application. No, it's infected application. You need to run the application. So if we trigger a couple of entry point for the Dreamdroid code. So it started by looking some profile. If it's there, it's going to stop. And it's also check if there is any application called Download Manager is installed. If it's already installed and it's stopped. So for analysis perspective, you know why application check for something on this. Maybe try to prevent him from to do it, double installation, or maybe it's one, some detection against this application, right? So, but it's also good to analyze on this one because the next logic here, if it's not installed, then you remove a file called SQLDB to something else called download provider manager.apk. So when you search, when you unzip the APK file, APK, as you know, is just a zip file, right? So when you unzip the file, you probably notice SQL.db. So SQLDB is pretty much the default implementation for this is probably to to store data, right? But in this guy using in different way. So this is basically, well, it's a different name, which is, this is basically a PK, another Android application. Okay, so you just copy to a download provider manager APK. So this is the code. It needs to start from launch, and this is the file is do something else. Okay, and it's also try, if not exist, try to do destroy. So destroy is basically try to root your box. Okay, and the last is going to copy itself to the SQLite.db to the download provider.apk. Okay, so this is on the first payload. Okay, the first that been bundled with the infected application. It's also reaching the phone. Why want to root your phone? It's not try to help you to jailbreak your phone. It's basically try to get root out of it. So the main reason to get root here is to achieve this copy file. So if you manage to copy the Android application to the slash system, when you view any install application, you're not going to find it because it has a root privilege and then it can be run stealthily. Okay, so that is the goal of reaching the phone. Okay, and this is the exploit. The first one is UDAF, and the second one try to use ADB root. So this is the code. This one going to run UDAF, so go for root, and it's also go for root as well. Okay, so this is how they call the function to root your box, right? So this is UDAF. So this is UDAF has also been bundled as a APK. So if you take a look at the sample here, so it gives you some like prepare raw file and install to change Wi-Fi state to change to something to trigger bugs, and then you can start do some exploit on the bugs. Okay, so there is a condition need to be met by UDAF root. Okay, for example, try to change the config Wi-Fi state. Okay, and then this one is, I think, on the second exploit. So this is also prepare raw and then run exploit as well. This also have a calling function, calling home. So like I said, it's all have a bot capability, right? When it's installed on your machine, we contact his home, right? To update whatever you want. In this case, it's still a bunch of information. This is kind of very crazy. It's still pretty much everything. Your email, not your email, your email numbers, your phone numbers, any SMS, your SDK version, and any application install. There are many things these guys steal. And it's also try to encrypt, well, I don't say it's encrypt, try to obfuscate the URL. You notice here, this function, and you call post URL. So when you post URL, you need to pass function, right? The parameters. So probably the link of the URL, right? But here you don't see it because that is the way it called, like try to get object out of the setting this function. So you need to analyze the on this file. So this is pretty much the file setting something, right? So this is the way it's set. The file. Sorry, this is the function that set the URL. Okay, it implements doing something, a click here, and it do some run, and this is the data that we want to analyze, right? So this is the creep function. So if you analyze function of the creep, if you take a look here, this is also try to get key value out of data from this data of ADB root key value, and also try to get byte and doing some XOR. So it's pretty much more or less it's doing some sort of XOR for each key. Try to do like data XOR with the keys, all right? And this is, if you do XOR operation, you will find this URL, okay? While stealing information, this is thing that is still get email, get MSI, and also there are many things. I just keep a couple of things here, like client info, partners, product ID. There are many things, right? So this is on the second payload. The first one is attached with the infected application so that it can draw their download provider manager. Okay, the download provider manager try to install within the slash system apt, which can be running stuff. And what it does, well, you need to do reverse engineering on the Android on this download APK. It's also stuff from Android manifest.xml2. And based on my analysis, it's pretty much have a lot of communication with the CNC server, more or less a bot. Features on this Dream Droid is have encrypted ZOR, have two payload, two-stage payload. The first payload is to root the device. The second payload is to receive instruction from the CNC. So Zeus, anyone of you heard about Zeus malware before? I think Zeus is kind of very famous financial malware. So it's also somehow infecting the Android as well. So part of bigger financial malware package is from Zeus. Well, this package focuses on more on man in the mobile, which is, we call it ZMO, which is a Zeus in the middle, Zeus in the mobile, which is used to run on Symbian before, or also run on Win Mobile, and also now run on the Android. The way of infection is by infecting via the fake application, okay, which is have some relationship with the previously installed Zeus malware. So the way we spot this relation between the Zeus binary and Zeus on the Android, due to the fact that both Zeus binary and Zeus on Android is connecting to the same server. So if you install this application, well, if you have APK, normally you can install, right, to do some dynamic analysis. So if you install application, it gives you this icon. If you're familiar with the trust here, you're probably aware trust here is doing a lot of research to fight with Zeus. So kind of social engineering for me, which is social engineering always works. So this is social engineering, like when you click on the application, because you probably want to click that, because based on your observation here, this is like trust your report, right? Which is need to do some validation. So you pass a couple of validation here, and all of your SMS will be still by this guy. So we take a look again at the Android manifest. It says here, whenever SMS received, you're going to activate SMS receiver. As you take a look at SMS receiver function here, so this is the SMS receiver function. It's like a create from PDU, get originating address, get message body, and the next is send data to the server. So Zeus droids pretty much the component is mainly just to steal any SMS data. It's very primitive compared to its cousin from BlackBerry or Symbian. The bad thing about this is just steal every single SMS received, which is kind of, for me, it's kind of dumb, can I say that? Because, running on phone, and then if you have constantly connection to the remote server, then you can somehow create some sort of red flag, right? Why you need to have instant connection, right? So I think maybe they just only need to steal SMS mobile banking related only. And then it's send SMS to this server. And then by using some init URL and push data to this particular URL. This guy, why this guy didn't use a method on like sending over SMS? It's going to be crazy because every single SMS received, there is also another SMS going out, right? So it's not very practical. But it's sending through this. I think he's thinking probably a good idea. And then another good thing about Android now is a new addition to family. This is SpyEye. People done dealing with the Zeus, and Zeus sell the code to the SpyEye kind of thing. So the guy from SpyEye, okay, let's go to the mobile, because everybody is talking about mobile now. So is Zeus, we call it Zitmo. What do you guys predict on SpyEye? Speedmore, right? SpyEye in the middle, in the mobile. So this is on SpyEye. So pretty much part of bigger financial malware package again, but this one is on SpyEye. This focus, like I said, is pretty much similar. This is interesting because it's infecting by fake app, which is caused by infected application, infected by SpyEye desktop. As we know, SpyEye boundary normally infecting on Windows. So, and we know on the SpyEye, you have a web inject, right? SpyEye have like a BHO, browser helper object. So when you try to go to like, for example, bank, whatever, so if that you are a part of the web inject kind of data, so it will pop up a new JavaScript or whatever, you know, pop-up, or can I say pop-up, or unintrusive pop-up to do something. And this case is also interesting. This specifically, well, it's said in Spanish, I think. Anybody read Spanish? I don't. I just got this information via SpyEye. So we receive SpyEye. So when you reverse SpyEye, you can get a config.bin, right? Inside the config.bin, there is a plugin for that webinject.txt. So if you have webinject.txt and you're looking some of data, it may have the data. So in this webinject, it works this way. You have machine infected with SpyEye. So if you go to the online banking like online bbva.com, and this is part of the injected URL. So SpyEye, we pop up this message like this is config, right? But in real browser, it will just show this stuff. So it's mentioned this is kind of like a new improved security, blah 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 blah, and it's also like, okay, whatever it is, try to install our new security tool. This is the URL, so please download and make your life happier, right? So give you this URL within your browser, okay? And then, I think all of us are smart, right? If you have like, if you don't have Android and this guy gives you Android application, are you really going to buy Android phone to just install this random application? Probably not, right? But, well, not all people are smart somehow. So that is the case people download this and install into their machine. Not their machine, install into their phone. So they got infected with the Zeus. So this is the file. This is within the browser. Credit on this one is from Trustier. It has the Spanish translation on this one. It mentions some like this is new features and blah blah blah. Now you can pass the authorization. You know, is the phone and the bank security system. So now all the mobile banking need to go through through this application now. So being humble, we just install application, and then what it does next is start to do a bunch of things like the application that pretending to be from the bank is need to have internet. It also need to send SMS. And also the good thing about this is try to read your phone state and process outgoing call. I mean, that's probably generous from the bank try to do this kind of thing, right? And similar to the previous sample, you take a look here, is any SMS received or any new ongoing call, please enable this function. Oh, no, please activate this function. This is the receiver of the function, right? So you reverse this. So you take a look at this function SMS receive. So you try to, this is you receive this kind of, event. Try to get some data out of this setting.html. So instead of doing immediately like post URL or something, this guy tried to do something else. Try to read within the setting.html. So there probably might be something inside the setting.html, right? So we take a look at setting.html. So you can find out a lot of domain names here. So you have like whatever blah 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 /ms gate.php. If you tracking spare or Zeus, gate.php is probably the instant indication that you are dealing with the Zeus or spare. So this within the setting.xml is the calling home for this spare application. And based on function, based on numbers from this code, we do the perform action. Because you have the two ways of sending back the stolen information to the attacker. It implement by using sending SMS and also by using a URL based on this location. Okay? And so that's pretty much the sample. It's relatively straightforward. There is no magic when you reverse engineering Android application. So challenge, when I say no magic, but that is also a challenge when it comes to reverse engineering Android. Well, Android malware is probably still premature, I would say. I won't say Android is not mature. Android is probably well established, but Android malware is probably not there yet. For example, doing some weird, hooking and stuff like that. We don't see any, well, based on my limited knowledge of publicly available method, I don't see anything like that yet. Okay? So in the future, you can probably expect something like have like a rootkit capability on the Android platform. So a couple of normal reverse engineering challenge, code obfuscation. When you start reversing an Android, if you start with dealing with a normal like ProGuard, it's by default will be turned on. But if you get used with that, there is nothing much on the obfuscation on the ProGuard obfuscation. Encryption, well, it makes analysis harder. Eventually will be broken, especially based on current sample, because you include your keys and your data within the sample. So sooner or later, people will discover that, right? So this is not really good. And code optimizing, as we know, a phone is very limited kind of resources, so it needs to be optimized. While it's good for devices, but it's going to be painful for reverse engineering. And of course, a couple of challenges like anti-analysis. Pretty much people like, the common practice probably drop application into like, VM. For example, we can do a lot of anti-emulator. Like if I can fingerprint email, for example, email for like your Android XDK is always written 000. So if I have email 000, I'm not going to execute anything, right? The typical, VMware kind of anti-analysis. I can also do like phone numbers, and of course within your emulator you don't have phone numbers, so I can fingerprint it on that as well. Well, kind of similar to VM detection, right? Anti-emulator. So how to solve this problem? Try to patch emulator. After all, emulator is open source. You can patch whatever you want, and you also can run via QEMU instead of running emulator. You can run over QEMU. You can do a lot of patching on that. And of course, the compiling problem. For reverse engineer, if you can have like translation from DAX to Java, that's probably awesome. Well, of course, it's depending. If you kind of like hate Java, you're probably not happy with that as well, right? So converting native Dalvik to Java, DAX to Java is a good example. Code logic confusing and incomplete code decompiling. This is the two common problem I normally face when I start reverse on Android malware. So for example, take a look at this case example. Well, you have case 2 and then you go somewhere, do something, it's continue. So for me, my personal opinion, I think this is much easier for me to understand. It do some switch for you, like a back switch 0, this is default, and switch 2, do something compared to this switch, right? Of course, it's depending on where you're coming from. If you like Java, you probably enjoy Java, then I hate Java. So it depends, right? And so decompiling error, you're thinking that, okay, cool, we can decompiling everything to Java, but good luck when you're dealing with some optimizing code, it's normally break. So you end up like, oh shit, I have to go and learn all this Dalvik bytecode again. So you have to learn all these weird dupe LDC, invoke special, or whatever. You have to go back to square one again and learn all the Dalvik bytecode. Right? So that's part of a couple of problems. And this is not related to reverse engineering, but this is also common sense, like how do you spot the malicious application? Out of thousands of applications within the market store, how you spot this is malicious, right? Of course, it's easy to blame Google, but I don't think that is a solution, right? Because that is third-party, Android market as well, right? So, how you trace that? And of course, thing that needs to be interesting is doing some remote install via market, and also like a remote uninstall by Google. If people can abuse, then that probably is scary. Someone can like execute something, and it will wipe out application within your phone, right? So this is also part of issue, I think, rather than the challenge. And conclusion out of this, I think Android malware is just a topic. More complex Android malware are expected so that we'll be ready. And then more exploit on an Android platform are expected. Now people are attacking more on the core application, like a browser and stuff like that. But I believe in future people start to break third-party application. And more powerful hardware, I think, will change the landscape. For now, like people doing DOS over your tablet or whatever, so it's depending on how the tablet moves, I think, right? And it's possible to reverse engineering Android malware, and understanding Dalvik is a must. And for reverse engineering, pretty much solving a puzzle, right? Get piece of puzzle, one by one, then I think you can solve the reverse engineering. Well, reversing repackaged application is not fun. Meaning that if someone repackage your app and start to put any malicious application, any code inside there, it's not going to be fun. So because it's huge code based. So if you have something like drifting tool to check the different, that would be awesome. But the problem is how you know which one is the original. That's because it's hosted in market store. You think that is original? Well, probably not good assumption, right? A couple of reverse engineering tools are out there. A lot of effort from community, especially from the HoneyNut project. And we are part of HoneyNut project. Like a droid bot for the dynamic analysis. APK inspector is pretty much, try to build a sweep tool to analyze Android application. Of course, tool Android Guard is also a good tool. And then, the last one is, have you tried HoneyNut Forensic Challenge 9? It was focused on mobile. We code the challenge inside the challenge. We did a bunch of things like anti-reverse engineering. We also do some like targeted attack. So feel free to do. And I guess that's all from my presentation. So if you have any Q&A.
Feel free to approach him on the ground. He'll be around.
Yep.
Both today and tomorrow.
Yep. Oh, if there is no question, then thank you very much for your time. So if you're interested to do some fun with the JavaScript, the obfuscation, we're going to do like lightning talk, second talk at the track 3. So feel free to come. Thank you very much, guys.
Thank you very much.